Welcome to Borishal Cadet College. I am S.M. Atikur Raja, lecturer, Department of Mathematics, Borishal Cadet College, Borishal. Boys, I hope that you are well by the grace of Almighty Allah. Due to Corona pandemic, I could not take your class in your classroom. I have to take your class virtually. Coronavirus is like the flu. Children very rarely get sick, but it feels like a cold. Be careful and tell your parents or teacher if you don't feel good. Tell an adult or your teacher if you don't feel good, you have a cough, your head hurts. For your safety, stay at home, wear mask, wash your hands. Now, I am going to take your higher mathematics second paper class for class 12. Today's topic, motion of a particle moving in a straight line or a plane, from chapter 9E. Learning outcome. At the end of the lesson, you will be able to know about determine the path of a particle, determine range, finding height. Because now we discuss a theorem. The path of a particle projected horizontally from a point at any height above the ground is a parabola. It's a board question. At first, we draw the figure. Here, this is y-axis, this is x-axis. We have to find out this is a parabola. Let the horizontal line OX, vertical line OY represent x-axis and y-axis respectively, where O is the origin. This is horizontal line and this is vertical line. These two lines intersect at the point O. Here O is the origin. Let O be any point above the ground and a particle be projected from O horizontally with a velocity v. But here from this a particle is projected horizontally with a velocity u. At any time t, let the particle reaches at the point P. After time t, here the particle reaches at the point P. The coordinates of P is x, y. Here OA equal to x, PQ, that means here OA equal to x, OQ equal to y. Angle of projection alpha equal to 0 degree. Here OQ, not PQ. So at time t, the horizontal displacement of the particle is OA. OA equal to u cos 0 degree into t, because the particle is projected at the angle 0 degree. So here the distance OA equal to u cos 0 degree into t. Boys, you know, cos 0 degree, that means 1. 1 into u into t, that means ut. Here the distance OA equal to x. So from this we get t equal to u by x. And vertical distance y. Vertical distance y equal to u sine 0 degree into t plus half gt square. But you know, sine 0 degree equal to 0. So here vertical distance y equal to half gt square. This is equation number 2. From 1 and 2, this is equation 1, and from 1 and 2 we get y equal to half g t square. If we put the value t equal to u by x, then we get y equal to half g x by u t square. That means x square equal to 2u square y by g. X square equal to 2 y square u square y by g. If we let 2u square by g equal to 4a, then the equation becomes x square equal to 4ay, which represents an equation of a parabola. This equation is free from t and represents a parabola. This equation will be the same for all position of the point P. For all position of the point P. Therefore, the path of the particle is a parabola. Now we discuss example 1. A projectile is projected with an initial velocity of 21 meter per second and at an angle 30 degree with the horizon. Find its range and greatest height. Solution. But we know that if a projectile is projected an initial velocity of u and at an angle alpha with the horizon, its range are equal to u square sine 2 alpha by g. Here, initial velocity u, that means 21 square into sine 60 degree, because alpha equal to 30 degree, so 2 alpha, that means 60 degree. The value of g equal to 9.8. After calculation, boys, you get 38.97. Here sine 60 degree equal to root 3 by 2. Was you know the greatest height equal to u square sine square alpha by twice g. Similarly, if we put the value of u, alpha and g, then we get 21 square into sine square 30 degree into 2 into 9.8, because the value of u, that means initial velocity 21, the angle is 30 degree, the value of g equal to 9.8, then we get, after calculation, we get 22.5. So here range 38.97 meter and greatest height 22.5 meter, which is our required answer. Example 2. A balloon is moving horizontally with uniform velocity of 196 meter per second, and a stone is let fall from the balloon, which reaches the ground in 5 seconds. Find the velocity of the stone when it falls on the ground. Solution. Let the height of the balloon is h and the stone reaches on the ground with velocity v. According to the condition angle of projection alpha equal to 0 degree, then we get h equal to minus u sine 0 degree into t plus half gt square. Here the value of sine 0 degree, that means 0. So here we get 0 plus half into 9.8 into 25, because for any value of u sine 0 degree equal to 0, that means 0. This term is 0. Here half g, that means 9.8, and the value of t is 5. That means t square equal to 25. After calculation, half into 9.8 into 25, that means 122.5. Again, v equal to minus u sine 0 degree plus gt. That means 0 plus 9.8 into 5. Finally, we get 49 because the value of g is 9.8 and the value of t is 5. Height 122.5 meter and velocity 49 meter per second. Now we discuss another problem. Example 3. If t be time taken by a projectile to reach at the point P, it also takes more t1 seconds to reach the horizontal plane of projection, so that the height of the point P is h equal to half g t t1. This is a board question. At first, we draw this figure. Here, h indicates the height. This is horizontal axis, this is vertical axis. They intersect at the point O. Let the projectile is projected at an angle alpha with velocity u from the point O. But the projectile is projected at an angle alpha with velocity u from the point O. Height of the point P is PQ, that means h. According to the condition time of the flight, that means capital T equal to T plus T1. Here, time of the flight equal to twice u sine alpha by g. From this, we can write u sine alpha equal to gt by 2 and h equal to u sine alpha into t minus half gt square. But from this we get u sine alpha equal to gt by 2. So here get gt by 2 into t minus half gt square. From this, if we take common half gt, then we get capital T minus t. That means half gt t plus t1 minus t. From this, t minus t, that means here remaining term is t1. But finally we get h equal to half g t t1. But now we discuss another problem. Example 4. Range of a missile is 1000 meters. If the acceleration due to gravity of motion is 1/6 of that of the Earth, find the range on the surface of the moon under the similar circumstances. Solution. Let a missile be projected at an angle alpha with horizon on the surface of the Earth with velocity u. Its horizontal range are equal to u square sin 2 alpha by g. Boys, that means 1000 because range of missile is 1000 meters. Let the acceleration due to gravity on the surface of moon be g1 and the range of the moon under the similar circumstances r1 equal to u square sin 2h alpha by g1. That means here 6 into u square sin 2 alpha by 6 g. That means 6r. That means 6 into 1000. Finally we get 6000. So range of the missile on the surface of the moon is 6000 meter. Now we discuss another problem, which is example 5. A cricket ball is projected so as just to clear two walls of height A and B at distances B and A from the point of projection respectively, so that its range is r equal to a square plus ab plus b square by a plus b. Solution: the ball is projected with velocity u at an angle alpha with horizon from the point O. The ball crosses two walls of height AB and CD. So here friends are for the wall CD b equal to a tan alpha 1 minus a by r, which is equation number 1. For the wall AB, a equal to b tan alpha first bracket 1 minus b by r, which is equation number 2. If we divide 1 by 2, then we get b by a equal to a by b into r minus a by r minus b. From this, we get b square first bracket r minus b equal to a square r minus a. After calculation, if we multiply this term by b square, then we get b square r minus b cube equal to a square r minus a cube. Here, if we interchange this term, that means side change, then we get a cube minus b cube equal to a square r minus b square r. So boys, if we take common here r, capital R, then we get r a square minus b square, and if we change the side and divide this, then we get r equal to a cube minus b cube by a square minus b square. That means r equal to this term, because a cube minus b cube equal to a minus b into a square plus ab plus b square, which is a cube minus b cube formula. But you know, a square minus b square equal to a plus b into a minus b. Here a minus b vanish. So finally, boys, we get range r equal to a square plus ab plus b square by a plus b. Boys, now we discuss shortcut technique only for MCQ. A body is projected at an angle alpha to the horizon so just to pass two walls of equal height A at a distance twice A from each other. Then its horizontal range is r equal to twice A cot alpha by 2. Was here example, a body is projected at an angle 60 degree. A body is projected at an angle here alpha, angle is 60 degree. With the horizon so just to clear two walls of equal height, 3.5 meters at a distance of 7 meters from each other. What is the horizontal range of the body? Was here short technique, that means short formula is r equal to twice a cot alpha by 2. Here twice a equal to 7, twice a equal to 7, alpha equal to 60 degree. Here range r equal to twice a cot alpha by 2, that means twice a equal to 7 cot 60 degree by 2, that means cot 30 degree. But finally we get 7 root 3 meters because the value of cot 30 degree equal to root 3. Homework was here given a CQ. In time of batting, a cricket player hits the ball with a velocity 20 meter per second and at an angle 35 degree with the horizon. A fielder standing on boundary line caught the ball at a height 1 meter from the ground. Find the time of flight of the ball. Find the greatest height of the ball along with required time to reach there. What is the horizontal distance that the ball described before the fielder catch it? Try to solve this CQ question based on previous lecture. Boys, coronavirus has stopped our life. Follow these easy steps to help prevent the spread of COVID-19. Disinfect surfaces around your home and work. Wash your hands for at least 20 seconds. Cover your mouth when sneeze or cough. Try to avoid public gathering. Follow the rules of World Health Organization so that you can save yourself from COVID-19. Thank you.